Alright, so this is the next video on linear programming, and if you haven't watched the first one, make sure you watch the first one before you watch this one. Okay, and so it's basically the same question. It's just the function and the objective function and the constraints are a little bit different. So, again, it says find the minimum, and maximum value of the objective function subject to the given constraints. And so, again, the idea here is, this is the function that we're trying to maximize and minimize. But we can't pick any x and y value. We have certain constraints on which x and y values we can pick. So to figure out what those values are, we graph these inequalities, these constraints, and they tell us which x and y values we can pick. And then from those values, we plug those into the objective function, and they tell us what the maximum and what the minimum values are. So again, the first step for these is to always just draw or to graph the inequalities, the constraints. And so let's go ahead and start off by doing that. So this first one, x is greater than 0. So again, that's a vertical line that goes right on the y-axis there. And then the y is greater than 0 is going to be on the horizontal axis right here. And there we go. And so again, if we were going to do the shading for just these two lines, we would say greater than x is greater than or equal to 0 and y is greater than or equal to 0. So that's to the, this first quadrant grid. It's all the way up here. It's all these. Oh, not down there, right? It's above this line. So let's erase that so we don't get confused. Okay, it's everything above the x-axis and everything to the right of the y-axis. Okay. All right. The next constraint here is 2x plus y is less than or equal to 8. So again, I'm going to put that in slope-intercept form. And so to do that, I'm going to subtract this 2x to the other side. And so let's draw it up here. What I'm going to get is y is less than or equal to negative 2x plus 8. And so that right there, I just subtracted 2x to the other side. And so this is my same equality or inequality. It's just now it's in slope-intercept form. And so let's graph this line. So I'm going to start at 8. So I'm going to go up 2, 4, 6, 8, and put a point. Okay, and then from there I'm going to go down 2 over 1. My slope is negative 2 over 1, right? So down 2 over 1, and so I'm going to go down 2 over 1, put a point, down 2 over 1. And you probably right there, if you remember from Algebra 1, they teach you you need 2 lines or 2 points, or sometimes just 3 points, depending on the teacher, to draw a straight line. And that's true. I could probably draw a pretty accurate line right there, but what I like to do with these, because it's actually really important that we get the vertices correct, is just to continue down until I run into another line. So I'm just going to keep going down 2 over 1 until I run into this this horizontal line here. So I'm going to go down 2 over 1, down 2 over 1. And so now I know for a fact that this y is less than or equal to negative 2x plus 8 is going to cross through this horizontal line at that point right there. And I'm confident because I counted the slope. Okay, so I'm going to draw a line anyways still. So let's draw a line here. See if I can get this. Okay, that's good. And I'll just shift it up here. So there's that line, and we'll worry about the shading for this one in just a second. So let's graph the fourth line. Okay, use a different color. So over here, this equation, I'm going to first subtract x to both sides, right? So what I'm going to get is 3y is less than or equal to negative x. Oops, I don't know what happened there. Negative x, what am I going to have? Plus 9. And then to get y by itself we're just going to divide by 3 on both sides. And so y is going to be less than or equal to negative x over 3 and then plus 3, right? 9 divided by 3. Let's undo that so we can actually read it. Negative x over 3 plus 3, right? I got that 3 because 9 divided by 3 is 3. All right, so let's plot this point or graph this line or this inequality. So y is less than or equal to negative x plus 3. So I'm going to go up to 3 on my y-axis. So 1, 2, 3. I'm going to put a point. And then my slope is negative 1 over 3. So I'm going to go down 1 over 3. So down 1 over 1, 2, 3. And it looks like it's going to cross right there, which is good. And so that right there is going to form another line. And let's see if we can draw that. Let's make it as close to accurate or perfect as we can. Okay, so what we need to worry about now is where we're going to be shading. Okay, and so we know it's going to be in the first quadrant because of these first two constraints. The second line, it says y is less than. When it's less than, it means it's below the line. So this is the y is less than or equal to negative 2x plus 8 line. So it's going to be less than that line, so it's going to be below this line. It's going to be below this line, so it's going to be down here. And then this other line, it's going to be negative. If y is less than, so it's also going to be below this line. So it's below both of these lines, okay? And so that means it's got to be in this area right in here. Okay, so that's our constrained area. Okay, and so that tells us which vertices we need to check. And so let's see, we got 1, 2, 3, 4 vertices that we need to check. And basically, out of those, we just plug those 4 points into this objective function, and whichever one's the largest value will give us the max, and whichever one's the smallest value will give us the min. So let's start off by doing that. Here we go. So this is the point 0, 0. We plug that in, we're going to get 5 times 0 minus 2 times 0, and so we get c is equal to 0. Alright, this is the value 1, 2, 3, so that's going to be the point 0, 3. We plug that in, we get c is equal to 5 times 0 minus 2 times 3. So 5 times 0 is 0, negative 2 times 3 is negative 6. So we get c is equal to negative 6. All right. This is the point 1, 2, 3 up 2. So that's the point 3, 2. So we're going to have c is equal to. See if I can actually write here. 5 times. What's my x value here? 3 minus 2 times 2. And so I got 15 minus 4, or c is equal to 9. Okay, and in the last value here, that's 1, 2, 3, 4, 4, 0. So we got 4, 0. And so that's going to be c is equal to 5 times 4 minus 2 times 0. And so that's going to be c equals 20. Okay, so if we look here, the maximum value is going to be the largest value, which is 20. So this is our maximum value. And the minimum value is going to be negative 6 right here. Okay? And then these other two values we don't even worry about. We only care about the max and the min. And so the max is 20 and the min is negative 6. So that's the final video on linear programming. If you're still having trouble, I recommend going back and re-watching the videos. Okay, or raise your hand and get help either from a partner or from me, and then try the practice worksheets. Okay.